1.
How's it going, everybody? We are in Team 19061. We're working with AGM Container Controls. My name is Andrew Kisher. I'm a mechanical engineer.
My name is Marcus Griffin. I'm a mechanical engineer.
My name is Sydney Kinder. I'm an engineering manager.
I'm Abraham Marcus, mechanical engineer.
I'm Cole Spinelli. I'm an electrical and computer engineer.
I'm John Wagner. I'm a systems engineer.
All right. So basically, to introduce, we're going to go through briefly like what our project was and talk a little bit about it. So introduce it. The project was centered around optimizing the powder mill currently used by AGM Container Controls. It uses a mixer and a ball mill to combine and mill two substances, as well as a volumetric feeder to transport them between each other. The goals of this project specifically for us were to automate the system, reduce the total time and manpower of the process, prevent powder from becoming airborne, and maintain end powder consistency. And this will be done through our design, which uses a mixer, a volumetric feeder, a ball mill, and linkages that we design. So for the problem statement, AGM Container Controls has 3 problems that need to be addressed with this project. The first one is that the design team must find a more effective way to mix the 2 powders together. The second problem is to eliminate the need for most PPE. And the third problem is that the powder is not consistent with its batches. So we need to find out how to make that more consistent within each other.
Okay, my name is Marcus Griffin. I'm going to talk about the objectives. One of our main objectives for the powder mill was to make sure that we automate the system so we can reduce man labor as well as production time. Another big concept that we wanted to do was eliminate the need for protective personal equipment, and that would also reduce costs so our sponsor wouldn't have to purchase equipment. Another objective was to make sure that we had a consistent mixing ratio of 4:1 for the 2 substances that would be mixed together. And last but not least, we wanted to make sure that the volume was consistent, again, as well as the ratio of the powder.
So I'm Abraham Marcus. I'll be continuing with materials and methods. The goal of our design is to automate the system, reduce total time of the process, and prevent powder from becoming airborne, and maintain end power consistency. So the process uses a mixer and a ball bearing mill to combine all 2 substances. The substances will be processed through the ribbon mixer, fall through into the volumetric feeder, and then be pushed into the ball mill, which will process it and finish into a container. The manual labors are also reduced since it's just a linkage system, and a labor worker will no longer have to be transporting the substance. Now, with approaching the problem, we began with a critical design review in order to develop a block system diagram that conveys the electrical components and layout for our design. We included packages and models and drawings made to spec to ensure that all components will be fit and operate together well before purchasing. During the design process, every decision was based around cost and risk mitigation. The integration status review package is essential and improved or upgraded version of our previous design. The new system will increase consistency also and in the develop better substance along with an increase in productivity.
With respect to our results, we were able to run a number of tests. Unfortunately, due to not being able to complete the system, a number of tests also could not be completed. The first test that we were able to do is the size of the room. As you can see, that the system put entirely together is significantly smaller than the size of the room, which allows for employees to be able to maneuver around the system to operate it. A test that we weren't able to complete is the containment requirement, making sure that no powder becomes airborne during the process. We're confident through our drawings and our connections that no powder will be airborne when running the system, although we can't run this test through demonstration until the system has been built. With respect to automation, similar to the previous requirement, we're unable to test until the entire system is built. Test that we were able to run is the volume requirement, making sure that at no point powder will build up at the feeder or the mixer or the ball mill and make it so that overflows, causing powder to go airborne everywhere. We're able to confirm this by making sure that the maximum amount of powder we're ever putting in at a single point is less than the volume each component is able to hold. The final requirement that we're testing is the accuracy. Unfortunately, we are unable to test this until the system is complete. With respect to results, data reduction, and objectives completed, stated, the coronavirus made it significant dent in our project, being unable to work together. It also caused our mixer to be delayed, and we were unable to get it. However, we've since worked tirelessly with our sponsor and with each other to get all of our deliverables together. We made sure to get all of our drawings together so that when the part is delivered, our sponsor will be able to go in and finish up the project. Our analyses show that everything here forth should be fairly low risk.
Okay, so to kind of sum things up here, and mostly the important lessons learned in this entire project over the whole year, I think the most important thing we probably took away from this, and I'm sure everyone will agree with this, as well as other groups, is to just be able to plan for any event. Obviously, as we mentioned previously, a major event did happen, and that did cause a lot of issues as far as getting our parts here and configured the way that our sponsor wanted them configured. So that was probably the biggest lesson learned for this project, and you could honestly call that even a surprise even. For another important lesson we learned is just being able to focus on all the possible tasks that we can while the parts are in the delivery process. So for instance, the ribbon mixer was not here, and it won't be here until later after the semester is over, but to ensure that our sponsor can complete this and that we could deliver as many deliverables as possible, we made sure that all the other components were configured the way that he wanted them to be configured. Another important thing, and I think just this comes down to what we just learned overall in this entire year, is just understanding the design process and all the factors involved in that process and being able to, comply with whatever our client wanted in the product. And meet all the specifications they, desired. And I think that will help us in the future, and I'm sure all the other groups would agree with that as well. And I think another important skill too is also just the amount of collaboration required to actually fulfill the design and to fulfill all the requirements our sponsor wanted from us. We all had to work together and made sure we were all doing something that was required for the project, and I think it was really overall just a positive experience.
Acknowledgements and references. We'd like to thank AGM Container Controls for extending their company's resources and facilities to allow us to get a closer look into the design process. We'd also like to thank our sponsor, Jordan Bontrager, for being so responsive and helpful with our project throughout the entire year. We would also like to thank our mentor, Patrick Caldwell, for teaching us as much as he could about how the process for real engineering projects is navigated. The knowledge we were able to take away from this entire experience will not only help us immensely in the field of engineering, but also in understanding that life will not always go according to plan. Thank you.